All right, so next up, last but not least, is Mark. So Mark is the project manager and a web developer at Extension Foundation. And today's going to talk about how to build AI assistants for domain-specific use cases. And in this case, I think it's for land grant research. And please welcome Mark to the stage.
Awesome. Yep. Great. So I don't know if they planned it this way, but it worked out well because that's a good example. Our product is similar to the previous talk, but it'll be a good side-by-side comparison of a sort of a non-profit product versus a for-profit one, because he gave you a lot of good numbers on costs and things, and I mean I could give you some of those things, but you know, in a non-profit world, we're just not focused on those things quite as much. So I'm going to talk about ExtensionBot. So again, my name is Mark Locklear. I've been with Extension Foundation for about 10 years. Started out doing web development, sort of moved more into the project management space. The Extension Foundation is a small nonprofit you probably never heard of. We serve the Cooperative Extension Service. How many people know what the Cooperative Extension Service is? A handful of folks. You know, there's a Cooperative Extension branch in every county, and every state serves ag, farm, horticulture. Master gardeners often work through the Cooperative Extension. If you've heard of 4-H youth, the green cloverleaf, that's a part of the Cooperative Extension Service. So that's who we are and what we do. And again, we're a nonprofit that we serve the Cooperative Extension Service. This is Athena. That's the logo that Dolly created for me. I was trying to get the ag, and I wanted something sort of gender agnostic. So that was sort of what it came up with. Okay, I just put this slide in. You know, we're here again. A few folks have talked about this. The AI space is new, and I can't remember where I came across this, but I'm trying to share this in any of the talks that I give. You all are thought leaders, and you're going to go back and do things with AI. And I ran across augmented intelligence, and I liked it so much better than artificial intelligence. Generally, anything that's artificial is bad, right? If it's an artificial sweetener, if it's an artificial color, that's bad. And so I think that AI has gotten a sort of a bad rap from that standpoint. And, you know, the subtitle here is aims to improve human intelligence and capabilities rather than replace it. So I just like this a whole lot. So when I talk about AI, I always try to talk about augmented intelligence. So feel free to use that and sort of share that as a term, because I think I just think in general the industry will get more traction and people will feel less intimidated by it if we talk about augmented intelligence rather than artificial intelligence. All right, what is ExtensionBot? So ExtensionBot is a domain-specific conversational AI tool trained on cooperative extension data. It's live, it's in production now. You can go to extension.org/chat and use it there. And yeah, so let's just jump right in and look at an example of it. So this is a sort of a side-by-side comparison with ChatGPT versus ExtensionBot. Again, the previous talk was a really good one because we've seen similar results there too, where ChatGPT does pretty good with sort of general ag, you know, gardening questions, that kind of thing. But there's a couple things we do that we think we're doing it better than ChatGPT does. And so a couple things here. So number one, we're giving citations. I'll talk about the RAG model that we're using and things like that in a couple of the upcoming slides. But we're able to reference specific documents. All of the responses that ExtensionBot gives are based on research-based cooperative extension. Either they're often called publications or fact sheets on a given topic. So we're able to cite those, and we actually give references. The user, you can click on the little number up there, and then we also, in the Learn More section at the bottom, we also cite those. So, I mean, this is good for a couple of reasons. Number one, it takes a sort of black box scenario. Folks have talked about that some. Often, you know, we don't know why it's giving responses that it does. So it's good for the users to be able to click on those links and sort of read for themselves. From a testing standpoint, it's also nice too. If you do get what you think might be a hallucination or a response that just doesn't quite seem right, you can click on the links and actually maybe hopefully get a sense of why it responded the way it did. The localization, so notice the second paragraph here. You know, if you're in Oklahoma, and then it goes on to talk more. I'll talk about the configuration settings for ExtensionBot, but part of the settings, part of the configuration can be you can localize it to your state. So again, we serve land-grant institutions. This particular question was asked on Oklahoma State's extension website. So it's given a specific response based on the state of Oklahoma. And then if you'll notice, the references down at the bottom there are at least 2 of those are also linked to Oklahoma State too. So again, we've got the localization piece. At the bottom here, the answer reflects extension. Again, all of these responses are going to be based on cooperative extension data, so that makes sense. And then we also do a follow-up question too, based on the question that was asked. The user can click on that and it'll submit. So there's a suggested follow-up question. Okay, what's the technology behind it? So for the technical folks, this will make sense. I think, again, all of this is so new that, you don't know, is this what other folks are doing? This, I think, is a fairly typical RAG pipeline. It was nice to see other folks talk about the models and the configuration they've got. I won't talk as much about the left side here, but, again, we have an embedding model. Qdron is the vector database that we use to return matches. There's some re-ranking that's happening, again, based on whether there's a localization in place or not. Again, the relevant resources are passed off to the large language model, and then the response is sent back to the user. I mean, just on this side, real quick, we started out a long history about that. This project's about 3 years old, and we've made massive changes, like a lot of folks mentioned here. When ChatGPT dropped, that was sort of made us totally rethink how we were doing things. So really, the front end RASA is an open source framework for creating chatbots. We're still using the front end pieces of RASA, but other than that, all of the back end is the RAG pipeline that you see here. And then we're also doing some logging to our users. We have a separate system that users can log into, and they can view all of the conversations that their instance of the chatbot has had, the questions that were asked, in addition to the responses that they're receiving. Data sources. So again, I mentioned, so each extension service, each state sort of calls their publications different things. Again, some call them publications, some call them fact sheets. So you can think of each of those as a resource. And again, these are, they may be in HTML format. The Cooperative Extension Service historically loves PDFs. So often that's one of the challenges that we run into, is trying to process and parse PDFs. I'll talk more about that. But again, you can think of it, these could be anywhere from sort of a page in length. You can imagine a standard HTML web page anywhere from a page in length to 10 or more pages in length. But you can think of that as a resource. So how are we gathering this data? So we're taking a two-pronged approach. One is working with the land-grant institutions to provide us data sets. I mean, we market and we have conversations with land-grant institutions. And for those that are interested in working with us, they give us, we'll look at the data spec that we've got in a few slides, but we've got a data specification, so we basically ask them to give us a dump of their data based on the data specification. It's a JSON spec. Based on that data specification, we ask them to give us a dump of that data, and then we train our large language model on that. So that's sort of approach number one. Approach number two is just crawling websites. So for those land-grant institutions that are either apathetic about working with us, or, again, these are state institutions and state schools, just like other institutions or companies, they've got 20 other things that they've got on their plate. So having to work with this organization that they may have never heard of before, and having to create this data spec is just one more thing they've got to do. So for those folks who don't want to work with us that way, then we are writing web crawling scripts for those websites. Again, that has its own set of challenges. We use Python and Beautiful Soup. Again, if the structure of that HTML page changes, the script breaks. So that's just one more thing we have to do. But I think that data is king, and at least in my opinion, it's worth the effort to write and maintain those scripts. I will say, has anybody seen Scrape AI? I think it's what it's called. Python has a tool, and it's a web crawling tool that it has AI capabilities. I think the promise is it's a lot more robust than sort of current web crawling scripts out there now. The idea is if the structure of an HTML page changes, it's flexible enough and robust enough to be able to absorb that and sort of still gather data. So that's one of the things we're looking at. So this is an example of the JSON format or structure. So again, you can think of this as a web page or a single web page or a single PDF on a given topic. So title, link, pub ID, thumbnail, institutions, sort of on and on. We have a separate data set. Each institution or website that's crawled, has a separate data set that looks like this. So just to give you an idea of so we've got about 300,000 total resources that our large language model is trained on. The institutions, the size of the data sets or number of resources is a good way to talk about it, I guess, is, on the small end, we've got some institutions that we've got around 300 resources, and then on the high end, Oklahoma State is one of the bigger ones, Oregon State, Florida, they're in the 5,000 to 6,000 resource range. So that gives you an idea of this sort of data set. I mean, my sense is, like, compared to our previous speaker, ours is probably a lot larger than what yours is. But I mean, the point is, I think that if you're thinking about a domain-specific chatbot, you do need large sets of data for the tool to sort of be worth it, right? I have people come to me all the time and say, hey, I'd like to have a climate, I'd like to have a chatbot or a version of the chatbot that can answer questions on climate change. And of course, my first question is, okay, what data have you got? And they say, oh yeah, we've got a website. Well, the website's got 10 pages with maybe 10 or 20 blog articles on climate change. That's not enough to power a chatbot, to train a chatbot on to be able to answer questions based on those things. Now, the power of the data set that we're putting together, though, is, we haven't went there yet, but one of the things we're thinking about is topic-based. So rather than, again, having a regional focus, so, okay, if I've got 5,000 resources from the state of Oklahoma, I can answer questions on that, but beginning to tag the data based on the particular topic, and then being able to create instances of the chatbot. So, okay, of those 300,000 resources we've got, let's pull out anything that relates to climate change, and then have an instance of the chatbot that can respond to those types of questions. So, a lot of potential with the data sources and the data set that we've got. So, this is the data ingestion process. Again, whether it's through web crawling or institutions voluntarily giving us the data, again, the data inputs could be any of these things. Really, most of them don't already have JSON, so HTML, PDF is generally the format that we're looking at. There's some, sort of typical reformatting that goes on, cleaning up of the data sources, chunking, that's fed to the embedding model, and then, of course, that's put into Qdrum, which is the vector database. The chunking part, again, I'm not the AI engineer that's doing this, so I can't speak at a low level on exactly all the pieces that we're doing. But the data sources we get, the AI engineer we're working with has asked us to leave the HTML in the page, and he's using that, my understanding is, from a chunking standpoint. So things like paragraph tags, headers, things like that, he's actually using that to chunk the data. And we get better results based on that. So what does the implementation look like? So this is the full page, full screen version of ExtensionBot. Sort of a chat GPT feel. We've got some sort of priming questions here if you want. You can click on those just to give people a sense of how the tool works. I mean, one of the challenges we've got, and I've asked that of other folks, is, what kind of prompts are you getting? And I think, again, there's a learning curve for the user base. I mean, our tool, this question of who's the end user, I mean, it's available to the public, and it's also available to cooperative extension experts or extension agents who are out in the field. But, the the technical expertise level of these folks is all over the map. So some of them may have used AI tools, things like ChatGPT, and so they're good, or they may have a sense of what kind of prompts you want to use. But looking at the logs for the tool, we'll often see people who are just, they'll put a one word, they'll put a single keyword in. So I think there's this, again, there's this learning curve here for folks moving from typical search engine Google type searches to how do you interact with a large language model. And we've even had those conversations internally about how we handle that. Like, I'm on the side of, hey, if they just paste a single word in, the response should be, sorry, please give me a more detailed question, as opposed to, and some other folks feel like, well, we should be able to try and handle that or do more to work with them. So and again, all of this is new, so whatever approach you take, I don't think there's any right or wrong answer there, but it's interesting to see how people interact with the tool now and what kind of results they might get. So this is, so what you just saw was the full page version. We also have what we call the widget version. You all have seen this. You'll often go to a website, and in the lower left-hand corner, maybe you've got a little chat bot that you can click on there. So again, that's you can implement the tool in either way. The functionality is the same. You're going to get the same response from the large language model, whether using that full page version or this widget version. I'm showing you just a few, not the entire configuration options that we give folks, but the sort of important ones I've got highlighted here. Number one, list of states. So again, I mentioned the regional aspect of this. So cooperative extension is local by nature, and they're at the state level and even again at the county level too. So often the way the implementation looks, if you experiment with the tool on extension.org, the first link that I showed, I call that the sort of general instance of the chatbot. So if you ask a question there's going to be no regional or state bias there. It's just going to go out and look through the 300,000 resources we've got, find the best match that it can, and then give you an answer based on that. If you use the tool on Oklahoma State's website, it's configured specifically to favor Oklahoma State's resources. And actually the way it works is it downweights everything else, and then by virtue of that, it's going to, the Oklahoma State resources are going to sort of bubble up to the top. But the sort of general, what we've seen, the handful of states that have it implemented on their site, is that for, again, they're going to set their state setting, so it's going to favor their data. And the way we have the weighting set up is that, okay, if I can find a resource within this specific state, you want to return a response based on that. And okay, if I can't find anything within the particular state, then I can fall back on other resources that we've got. Alrighty, so these are the challenges. I went fast. So data gathering is one. I talked about that. Even though we're all nonprofit, you run into the same sorts of politics within universities and institutions as you do in other places with regard to data sets. You get this attitude, well, it's our data, it's not yours, even though my argument is this is taxpayer money that's funding this, so it's the people's data. It's not yours, although my CEO tells me that I can't say that, but I mean, in truth, that's what it is, right? So that's the argument that I make. Generally, we haven't run into issues like that, but again, you sort of often run into those sorts of things. The web crawling that I mentioned. So one of the things we're doing, we just got funding for this next year, is like right now the scripts are all just sort of one-offs that we run. We're running them every couple of months right now just to sort of get updated data sets, but one of the things we're going to do this next year is build a single platform that's going to manage all of that. So, a single platform where all of the data is going to live, so the participating institutions that are creating data sets for us, generally what we're asking them to do is they've got a single endpoint that lives somewhere on their university system. We can hit that endpoint, we can pull data down, and then again, the scripts are going to need to be ran on some regular basis, probably a weekly basis is what I'm thinking. But again, the goal there is to have a single platform where all of that data lives, again, whether it's a crawling script or whether it's an endpoint that we hit. And then that platform will be where ExtensionBot is going to pull and update data from. Location-based answers. So again, we're constantly tweaking that. Again, we've got a weighting sort of system in place. In addition, if you noticed on that slide I had with the list of states settings, it can be one specific state or actually can be a group of states. So the idea there is that from a regional standpoint, for instance, we're in North Carolina now, ideally, or one scenario or use case might be that, again, let's say North Carolina State had ExtensionBot installed on their website. You want to favor North Carolina State at the most, and then you might have South Carolina, Virginia Tech, and then Tennessee as sort of, preference 2, 3, and 4. Just an example, if I ask a question about muscadine grapes, well, muscadine grapes grow in the South. I'm probably going to get the most relevant answer from North Carolina State's data set, but then muscadine grapes are often grown in South Carolina and really anywhere in the South too. So if there's a better article based on a given topic, then you might want to return that resource too. So there's sort of constant tweaking that we're doing there to just be able to get the best answer, the best response back. Naming and synonyms of plants and insects. So the sort of farming, gardening world is notorious for having different names for things, right? Sorghum is one term, and then you'll hear molasses, you'll hear syrup. Often those terms are interchanged, and even at the research level, folks who are in the know can often use different terms for those things. Insects are the same way. Yellow jackets, bees, mud daubers. I mean, there's all kinds of colloquialisms that are used about given terms. So trying to train the tool so it sort of knows all those terms and will respond with a relevant resource based on that term is a big one that we try and deal with. The USDA actually has really good data sets that are, I guess for lack of a better word, taxonomy type documents that will take multiple terms that mean the same thing and sort of put them in a single place. So we've experimented in different ways with training the large language model on all those terms. Again, the goal is so that it understands that if there's synonyms for a given name or topic, that it's able to handle those things. And then cost is the last one. I've been really excited to see folks mentioning the smaller language models, not just for the cost, but then also the responsiveness too, because that's one of the issues we've ran into. We're constantly balancing. We're using Mistral now, and then we host our stuff on with Google Cloud, but cost is a constant issue for us. So I was curious to hear folks that saying they're getting good results with smaller large language models. Again, our previous speaker talked about the developer. I mean, we really are, and I've been in that role too as the technical expert. You're really reliant on the developer that you're working with to sort of make the calls on those sorts of things. And they're the experts, so you want to take whatever recommendation they give. But and again, I've been in that role before too. Often, what's easier for the developer is what they choose, right? As opposed to that might not always be the most cost-efficient thing to do. So that's sort of one of the challenges we have. I think that is all that I have. What questions do you all have? I mean, I made a good, just as a side note, John Dorner's here. He works sort of in the same space that I do, but they have a sustainable, they work for the USDA and sustainable farming. They've got a large database on sustainable farming topics. So we're gonna bring his data in, but go ahead.
This is a great tool. I know a lot of farmers who could probably benefit from it. How do they know about its existence? And is there a marketing plan for this tool in some way?
Again, small nonprofit. So the marketing plan is me and in HubSpot and the email list that I've got. So a couple of things. Again, we're we partner with the land grant institutions, and we somewhat rely on them. I mean, again, on extension.org, I've got a full-page version of the generalized chatbot there, so folks can experiment with it. But, I mean, I think the target audience or the target customer really is the land grant institutions. And, I mean, they're the ones that have a lot more resources at their disposal as opposed to we do. So, again, to use North Carolina State here in North Carolina as an example of that, ideally the cooperative extension, I think theirs is Ag and Resource Sciences is the name of the department at North Carolina State. They'll see huge value in it. They'll install it on their website. They'll share that. They'll share the gospel with the cooperative extension agents in the counties, and then those cooperative extension agents in each county will go out and tell farmers and other folks about it there. So that's probably generally the way things are going to go. Again, we've got an email list of 300 or so. We have IT directors. Each land grant institution has an IT director within the cooperative extension branch there, and so we have communication with them too. But
Have you gotten any pushback from any of the extension agents?
agents, no, and we're not seeing a ton. I mean, right now it's a relatively, again, Oklahoma State, Oregon State, and then Florida sort of have it implemented on their main extension sites. And I don't know how much marketing they're doing. I mean, we're still moving slow. I mean, you know, this could have, you hope folks are going to use these tools in the right way, and that's why I had the augmented intelligence slide there. I mean, you would hope a farmer wouldn't go out and ask ExtensionBot a question and then go out and maybe fertilize just based on, you know, the response that it got from ExtensionBot. You would hope someone from the public wouldn't ask about canning fruit and how long do they need to cook the fruit, or, you know, I mean, this could have some serious health and finance implications for folks depending on what they ask and how they used it. So at the moment, we really haven't gotten any bad feedback. I mean, we've talked about hallucinations some here, and we've been pretty. I mean, I've been impressed with the fact that we haven't. I mean, I was sharing with someone at lunchtime. I mean, I've even asked it some sensitive questions about, you know, what are some challenges African American farmers might face in the United States, you know, when it comes to farming. And I've gotten really, you know, what feels like thoughtful, good responses back. So, you know, we haven't had anybody really beat the tool up yet and try to take it down a bad path. But I think this RAG sort of model that we're using and having these, again, this domain-specific model where we've got trusted data. And, you know, again, all of the extension data is peer-reviewed, you know, sort of trusted data and data sources. I think that's given us good results as far as, you know, getting bad responses goes.
Have you had any issues with bots trying to abuse the platform?
No, I mean, no. You know, I've had that, you know, just again, coming from a web application developer's perspective, you know, doing post requests and things like that, though those are usually susceptible. But again, I can't say I'm looking at every question that's being asked. Again, we have a reporting system that allows us to go back and look at that. But I haven't seen any, we've not had any issues with that up to this point.
Awesome. We have 1, 2, 3. 3 more questions?
You know, I will say too, though, one of the things our tool does is if it can't find a relevant resource, it'll say, sorry, I don't have any information on that. You know, unlike ChatGPT or some other things, which really, I mean, you can ask it almost anything and it'll come up with a response. There is a threshold there where it'll say, sorry, I don't know anything about that. So.
Let's go to the green chair over here.
So hopefully I heard you right. Right now, you're reaching out to the universities and collecting information off their domain and pulling it and doing your search that way. In the future, you hope, my question is based on this being accurate. Mm-hmm. In the future, you're hoping that they will give you the information and you'll store it in a single repository, correct? Mm-hmm. So currently, you're kind of reaching out to all the universities, to their repositories and grabbing data during when the chat's asked or the question's asked, correct?
Right. If we have a data dump from them, either they've given it to us voluntarily or we went out and crawled their website, then when a question is asked, if a relevant resource is found from one of their data sources, then we're going to return an
But
answer.
the data source, does it exist on your server or
Yes,
is it out there?
that's as it exists on our server.
So
we
you're
have to
not
have
reaching out to their domains, grabbing stuff in live, dynamic,
real time? No, that's not happening in real time. Again, we're
I was
writing.
wondering, how do they maintain the security to ensure you're not accessing data that you shouldn't be accessing?
Well, publicly available data is all publicly available data is all we're training our large language model on, whether that be them giving us a data set, and we've told them, for the ones that are working with us voluntarily, we don't want some hidden data or something like that, because again, I'd rather not go there. There's a wealth of data that's publicly available out there such that we don't need to necessarily crawl into hidden spaces. And of course, the crawling scripts are only going to be publicly available data too. So.
I was wondering, first of all, thank you very much, Mark, for sharing your experience. Have you considered using a knowledge graph to model the data? Because as your data complexity grows, you could get a more sophisticated knowledge engine that would provide meaningful responses to more complex questions, have better contextual knowledge and ontologies about. And also I was wondering if you have thought about leveraging some open source knowledge graphs for agriculture data or plants, insect data, and that type of thing.
I don't know the technology that well to be able to answer that question. So
I think it should be something to look at.
But I'll look into that. Yeah. We've had really good, again, the sort of the model, the RAG pipeline, and the model that we've got. We seem to get good relevant results back. I mean, the testing part, again, our previous speaker, I'm envious of a lot of the work that they were doing. The testing part is super hard, right? A lot of this data is, it's domain specific, like down to the point of, when is the best time to wean cows from their mother? I'm just making that up. But you've really got to sort of know, you've got to have the right people, whether it's farmers or extension experts. And, extension experts really have a vast range. You have to have an extension expert who knows cattle and cows and that type of thing. So the testing part is difficult. Again, we've had some baseline tests we're doing where we're using ChatGPT to try to give us some kind of score on whether a response is good or not. But again, a lot of this stuff is so specific. ChatGPT does okay at responding to it, but whether we want to use that as a baseline for trying to decide whether a response is good or not. So that's one of the ongoing challenges we've got.
This will be the last question over here.
So I know you said from a marketing perspective, being a nonprofit, you guys lean on your kind of partner entity. Mm-hmm. So are you guys, when you contact the county reps, they're also disseminating that information to the farmers? Is that also kind of going to the FFA, Future Farmers of America, kind of education as a marketing tool to train the new farmers coming in?
So we're not at the level where we're communicating with farmers we're not at the level where we're really even communicating with cooperative extension agents directly. That's really up to the land grant institution within a given state and how they want to do it. I can tell you right now, none of them are comfortable enough, not even with our tool, but with the technology in general, to communicate with cooperative extension agents and sort of give them this tool. I mean, this is no shade on Cooperative Extension Service or those, but generally these are sort of old school folks who are, we're talking about farmers, gardeners, those kinds of folks. So their uptake of new technology is slow. So now the land grant institutions, generally these are, again, NC State, Virginia Tech, Clemson, these kind of folks. They've all got computer science departments. So they're, from a progressive standpoint, they're obviously way more interested in this. They see the potential to it. So a lot of what we're doing, even though I say it's in production now, it's really sort of at the university level. I think some agents are starting to see it now. We're starting to reach out. We're reaching out to the universities and saying, hey, if you have progressive, for lack of a better word, progressive cooperative extension agents who are willing to use this tool and give us feedback on it, please do that. Because, but again, uptake is going to be slow at the sort of ground level.
Awesome. Thank you, Mark.
Thank y'all.